So in this situation, many to many, what are the possibilities, by the way? The possibilities are that the student, right here, the student may have a collection inside the student class, which is the collection of classes. It may be just an array of references to class, to course objects, or something like that, or some sort of a smart collection, such as an array list in Java, for example, that you can dynamically grow and shrink and things like that. So that's a possibility. On the other hand, a course, once instantiated, will also have a collection of students internally. So there's a possibility that those two classes will have those collections. But sometimes to resolve this, and sometimes the way it works in databases, sometimes in the middle, when you have many to many relationships, you may create a cross-reference object, which basically will be referencing all courses and all students, essentially a cross-reference table-like object which knows about all intersections between the students and courses. So there's a little twist that there could be other possibilities with this design. But by looking at this diagram, my expectation is that student, once created, class student, once we create, new student with this name and this list of courses or something like that, then it will simply populate a collection of course objects, and they all will have references to these courses. And likewise, if somebody creates a course object, it will be populated with a collection of students who actually take the course. Now, by the way, this is somewhat oversimplified, because sometimes, often in the design, what needs to happen is that perhaps you have a section of a course, right? Just like, remember, we were talking about this performance theater, and it had performances, but those performances were, actually had the actual schedule. Here, once you create a course, you can have multiple sections which could be taught by different instructors or the same instructor. So there's a little bit under design or oversimplification, but still, you can then say that an instructor could teach a course, right? And so again, given the diagram, you don't have to grasp the entire thing to become comfortable. You can just kind of patiently examine areas, particular relationship in this diagram, and this can be very useful, because even then, if you're a programmer that has to write code for these classes or become client of already existing classes, and you need to essentially write your own methods that do some work with these classes to implement your own use cases, right? Then typically you don't work with all of these classes at once. You may be working with just one class and then working with another class, right? And as you basically doing this work, you will be referring to this diagram to find out what the possibilities are and how you should be writing your code as well, so that you don't violate any of these design decisions which describe particular relationships and so forth. So this is somewhat a bigger diagram and inconveniently stretched, right? Kind of like doesn't fit on one screen easily, but that's okay. That's the possibility, and it's okay. So another somewhat bigger diagram. Again, a diagram which I posted earlier on that shows a part of shows some components for a work schedule, right? So in this work schedule, we have the most important classes, I would think, here would be an employee and time slot, right? So clearly we have a work schedule which is composed of the time slots. Apparently the cardinality isn't shown here, so this particular arrow here doesn't display an asterisk, but it could potentially, because work schedule by itself quickly suggests that work schedule is a collection of time slots, right? And so, but once established, time slot could be of different kinds, and they can be weekday and weekend and holiday type of time slot, and even more varieties could exist, right? And you also have employee full-time and part-time. But interestingly, instead of using association between the time slot and an employee, right? There's no direct connection here. It happens here is that the employee has an ID, and in a time slot, an employee ID is provided. So the time slot object doesn't have a reference to an employee object, rather it has an employee ID. So perhaps if you're working with a time slot, all you get is employee ID, and based on that ID, perhaps you can query the database and query for information for for an employee with this ID, if your goal is to access an employee class. And then you may create that employee. That's one possibility. Another possibility with this design is that maybe there is some kind of map in the system that can give you an employee object based on employee ID, which is perhaps just an integer number. So then again, having the time slot, if you have access to the time slot, you can then ask another part of the system to provide an employee object because you want to access the employee, right? Kind of just an observation that on this particular diagram, there is no direct connection between employee and time slot of any sort, right? So that's okay. That's part of the design. It's sort of like the design decision. Perhaps the advantage of this situation is that if you want to create a time slot, and it does indirectly reference an employee ID, which of course each employee I would suppose will have, right? But the creation of time slot does not require you to create an employee class. You don't have to. You can work with time slots all you want. Perhaps you already know the employee IDs. There may be a collection of integers. And so you can create time slots. You don't have to create an employee. But if there was an association of similar to this, right, connection from the time slot to an employee, for example, then that would suggest that if I create a time slot, most likely, an employee object has to already exist, or maybe that use case that uses the time slot has to create that employee object as well. So there's another concern, right? So that's, again, each of these diagrams basically tells us the story. But guess what? Without documentation, the story, of course, is not fully complete unless you want to annotate heavily the entire diagram so that it becomes sufficient to understand, at the diagram level. But most diagrams could omit some of the details, and then, again, there should be some sort of a documentation accommodating those diagrams. So that's just a practical approach to this situation. So we started with this particular example here. So so these are examples. Again, perhaps this is a good one because it's a simple one to understand. And just before we wrap up this segment, also interesting observation is that recall that on some of these diagrams I had data attributes and I also had methods attached to these classes. And on some of those diagrams I don't have them, like on this one, just names of classes. Because the reason for that is that perhaps an extensive description of all methods and all data attributes is not as important in terms of understanding. Because remember, why do we have those diagrams? So that we can communicate our ideas to someone else. And the goal here is successful communication. For example, an expert user communicates a set of ideas with perhaps a help of technical writer, that they communicate the idea to a programmer or a team of programmers, right? So the idea here is to communicate information. Now, a programmer could create a class diagram with an intent to use such tool that once created, the class diagram tool itself can generate code. Specify what programming language you want and generate code. So, for example, rational rows and other products, commercial products, exist out there, which will allow you to create diagrams, but also generate code. Because these boxes, if all the attributes and methods are already specified, they correspond immediately to a software class that can be generated. Even a set of constructors and getters and setters can be generated. Why not?